Hello everybody, and welcome back. So this week we're going to be starting with Vex. And like I said before, we're going to be starting with quite a basic introduction for Vex, just to make sure that we have all the foundations laid out. So if you've used Vex before, you may know some of the stuff, but hopefully there's also a few things that you maybe don't know. So we're going to try and fill in all those gaps, make sure everybody's on the same page, and then we're going to move on to some quite advanced stuff from next week, and we're going to ramp up quick. So if you get lost after this point, I would suggest returning back to these first 2 weeks and practicing a little bit before moving on. Okay. And even if you've used Vex before, make sure that you understand all of this right now. Okay. So what is Vex? So Vex is an expression language built right into Houdini, and it's based on C, so it comes from the CVex coding language, and it has also a few features of C++ built into it. And the primary thing to keep in mind with Vex is efficiency. It is built for efficiency. So whenever you can do something in Vex that you can also do in another way, chances are the Vex way is the most efficient. Okay. So it can even replace entire nodes that are built into Houdini, standard nodes like the transform node or attribute create, and all these different nodes that are performing certain functions that we use on a daily basis can be replaced with Vex functions. Now, sometimes for convenience, it's easier to just drop down a normal Houdini node, but the Wrangle nodes, the Vex scripting, basically gives us a lot more efficiency. So especially when our scene is really large, when we're running over massive amounts of geometry and points, then you may need Vex in order to make the system run efficiently. Okay, on a small context, maybe with a standard box, then a normal attribute create is pretty basic. But when you have thousands and millions, hundreds of millions of points, then it starts becoming more efficient to do it using Vex. It also allows us a lot more functionality, because you can write conditions and perform you can perform a function, but only if a certain condition is met, and then vary it per point or vary it based on another attribute, which can only be done in sort of small packaged kind of contexts on certain nodes. But that wide variety of functionality can only be done in Vex. So not only is it more efficient, but it is actually also more functional. The only problem is you need to know the language. And the language is so easy to learn, and that's what we're going to be starting with now. So after this, you should be able to do most things just straight in Vex. All right. So with Vex, it's important to understand that it's quite contextual, right? So it is going to be different within each context that you use it. There may be certain functions that are the same across those contexts, but even a lot of the time, a function that does exist in two different contexts, like on SOP level and DOPS, will have different arguments, or will maybe perform the same or similar function, but actually just slightly different. So it is important to keep in mind what context you're working within, and to take that into account. Make sure that when you're looking in the help file for what that function does or which arguments it needs, that you're looking at the correct context. Okay, if you're working on DOPS, make sure you're looking for the DOP Vex functions, and that you're not just applying a SOP one and hoping for the best. Okay, so let's talk about the different contexts where you can find Vex, because you can really find Vex all hidden throughout Houdini. Like in every context, you can basically access it. Okay, so one of the primary ways is through SOPs. So that's the way we're going to do most of our Vex coding is SOP-based stuff, just because that's, what you're going to use. The majority of your Houdini stuff is done in SOP level. But you can also access in DOPS and CHOPS. So in all those three contexts, we're going to use Wrangle nodes. So you'll see in SOPs, there's our attribute Wrangle, or let's see if I type Wrangle, you're going to see there's an attribute Wrangle, and then okay, we've got deformation, height field, point, primitive, vertex, and volume. Now, okay, besides the deformation and height field and volume, these other ones are all actually the same thing. So if I drop down a primitive wrangle, it's actually an attribute wrangle, but just with run over set to primitives. Okay, same with points. So I mean, technically an attribute wrangle and a point wrangle are going to drop down the exact same thing. Okay, drop down a point wrangle. It calls it point wrangle here, but it is technically an attribute wrangle, and it runs over points. This is exactly the same thing. Okay, so those are there just for your convenience. If you feel like dropping down like a primitive wrangle or something like that, because then it just already has it set to primitives. But I mean, I just drop down, as you type wrangle, the very first one is attribute wrangle because it's alphabetical, it starts with an A, and that's the one that you're going to use the most anyway, and you just choose here which context you want. Okay, so the other two wrangles, so there's a height field wrangle and a volume wrangle, which also are kind of functioning similar. If you dive inside, you'll see that they're running through it's a snippet inside of a volume VOP, right? Whereas the other wrangle, so the attribute wrangle, is running a snippet inside of an attribute VOP. Okay, so it is important to note that when you're working with volumes, you can't just drop down a normal attribute wrangle and then write data to a volume. Volumes are not in this list here. Even though volumes will come up as a primitive, you cannot actually change the data of a volume in here. Okay, but you can do that through a volume wrangle, and then there's a height field wrangle as well, and then there's also a deformation wrangle. Okay, so this will have an attribute VOP inside as well as a transform by attribute. Sorry. So we've got these wrangles in SOP level. There's also a in DOP context, you'll also find a few wrangles. There's a gas field wrangle, a geometry wrangle, and a pop wrangle. Okay, and I mean a pop wrangle just has a geometry wrangle contained inside of it, so you can kind of just drop down a geometry wrangle and write any of your code in here. Okay, so that's DOP context, and you also have wrangles at CHOP level as well. So you've got a channel wrangle and a transform wrangle. Okay, so these are all just little areas where you're going to write snippets of code. So essentially, instead of applying a node that has its own built-in function, it's just an empty piece of, like a text field where we can write code, and then it will perform that function on whatever we tell it to run over, and then it spits out the resulting data and geometry out the end. So that's all the wrangle nodes are doing. Now, you saw that the wrangles actually contain a snippet node, so the wrangles are mostly there kind of for convenience. It's got all these settings of what to run over and the bindings and which attributes to match or to export. So this is for convenience, but ultimately what we're doing is we're running an attribute VOP with a snippet node. So you can also access those snippets if you're at VOP level. So we have, let's say, a point VOP. Okay, and we're accessing, we're writing stuff in VOPs, and then we want to add something. We can just drop in a snippet and actually write a chunk of code and apply that within our VOPs. Okay, now hopefully you won't really do this that often, because generally if you know the code, then you're gonna probably just do it all in code. Why use a VOP and then Vex code mixed? But sometimes you will need to do that. Okay, and then also similar to that, where you can access snippets, is in shop. So in your shop context, if you have a material shader builder or whatever material, and you're inside, and you can drop down a snippet. Okay, and Vex really was originally a shading language, so it is meant to be used to write shaders. If we drop down a material network as well, then in here directly inside of the material network, we can drop down snippets of code, and whatever values we export out of here, we can plug into our shaders and something like that. Okay, so you could write a snippet of code and use that to drive the surface, like the base color on the surface and a principled shader or something like that. Okay. So there's a lot of ways that you can access writing snippets of VEX code. Okay. Now you'll also find one more way that I do want to mention is inside of DOPS. Okay, look, it is on other nodes as well, but DOPS is the most prolific, where a lot of the nodes, I mean, let's say just maybe a pop force node, has a VEX snippet built directly into it. Okay, so you tick this on and actually you can write any of these data, like maybe your force, instead of setting it just in here using parameters or maybe a few variables, you can actually write code in here and have it set force using VEX. Same thing within this noise tab, it also has a VEX snippet just specifically for the noise. Okay. Slightly different syntax when you're writing these. You don't have to bind out your attributes. In fact, if you do, it won't write data. So it kind of accesses a little bit different, but we'll talk about that in a future lesson. Just keep in mind that you can also write it in here. Okay. And then the final context I want to talk about is just your variables. So last week we spoke about global variables, environment variables, and local variables, and accessing that using $, so $F for frame number or something like that. Okay, so then as we slide, it's changing the X size based on frame number. Okay, now I did mention this briefly last week, but I'll run over it again, is that we can access, so that the $F kind of style is being outmoded. Some of them are still used a lot, but the majority of those variables are being replaced with VEX style at references. Okay, so at and then frame, but it's with a capital F. Frame is the same as $F. In fact, it's the same as $FF. This will grab floating frame number. Okay, so it's the same as $FF, right? Which I did mention to you guys would grab half frames as well. Okay, so if I go and put at frame in here, it will get my frame number correctly the exact same way as $F would. But also here you see I've created an attribute called foo, and the old method would be to tick this on and have it actually create a local variable with the same name as your attribute, but all capitalized. So in our geometry spreadsheet, you'll see there's a variable mapping. Okay, and like I said, this is kind of outmoded now, so that's why this is by default now ticked off. If you're using a much older version of Houdini, you'll find that this is actually ticked on by default. Now it's actually off. It's still here if you do need it, but yeah, it's off by default because you generally shouldn't need it, because most parameters now will allow you to access attributes using the at syntax, the VEX syntax. Okay, so I've created foo and filled it with a value. So now on my transform node, I can just go and create, so let's say in my translate X, right, I just want to access this value. So I can say at foo, and then it will read my transform. Okay, that's maybe a bit much, so I'll say at foo times 0.1. And you can see that as I go, my frame number is increasing, so my X value is increasing as well. Okay, much easier. You don't have to have additional data for a variable map or accidentally lose the variable map and then your variables break. So it's just a lot simpler to use this. Okay, right. So that's kind of just a brief introduction to the context of where you can access VEX and kind of what it is and what we're going to be doing. Now, there's a final thing that I want to mention to anyone who maybe hasn't worked with much coding yet and maybe doesn't know VEX at all. It's very easy to become intimidated by having to write big lines of code. You know, it's so much easier to plug in a node, node after node, and kind of see what it's doing than having to actually write lots of lines of code. But I'd like you to keep this in mind. Writing code in any context, I mean, even not VEX, Python or something even outside of Houdini, just any coding, all it really comes down to is the getting, manipulating, and setting of data. So in other words, You want to get data, so asking the code or the program a question. You know, what, like for example, this I've got a box here, and I basically want to ask it, well, what is the point position of this point? Okay, tell me where it is in space. So that's getting data. Then you manipulate data. So you then maybe set a condition, or maybe just do some maths. So you just say, well, I want you to take that point and then add another vector to it. So add sort of maybe 1 along the y-axis. Okay. And then you're setting data. So you're doing something with that value. You've calculated a new value based on an old value plus 1 on the y. And then you're just setting data. So you're saying, well, now I want this point position to change. I want to set this point to this new position, which is 1 more along the y. Getting, manipulating, and setting. That is all, right? It's very simple when you remind yourself of that. So I know to anyone who maybe already thinks in code, who's already used to that, you know, this seems a bit redundant, but a lot of the time people avoid anything technical and anything that has to do with code because they don't understand that all it really is getting, manipulating, and setting. I've mentioned many times that nodes are essentially just little snippets of code. It's just that the code is hidden from you and you're all just accessing the exposed parameter values on the top level. Now if you look at a node, all it's doing is it's getting data, so its first input is getting, it's doing something with that data, so it's manipulating, and then it's outputting, so it's setting that data. Okay, get, manipulate, and set. Right, so we're going to remember that moving forward, and we're going to start coding. Okay. So thank you very much for listening, and I'll see you guys in the next lesson.